Hey guys, so my name's Ari,
And I'm Rudy.
and today we're going to be talking about simple harmonic motion in real life and in pre-calculus.
Okay, so what is simple harmonic motion? From our research, we found out that simple harmonic motion is a repetitive rise and fall of, say, energy over a certain period of time. So we compared it to how a spring oscillates around an equilibrium, and as long as it's repetitively going a certain displacement up and down in a certain period of time, that moment of time is simple harmonic motion. So the basis of it is having a constant displacement over a certain period of time. So how do we apply it to math? We apply it to math using two simple equations, sine and cosine. So we provided for you two functions for sine and cosine. And now we're going to talk about the parts.
So first there's A, which is amplitude. Then there's C, which determines phase shift, and the equation for phase shift is C over B. Then there's B, which not only determines phase shift, but it determines period, with the equation 2 pi over B. Then there's D, which determines vertical shift.
Mm-hmm. And the vertical shift raises your equilibrium, or lowers it. So we provided for you guys an example of a graph. So we use sine in this case, so we did y equals 2 sine 2x plus 1. So as you can tell, A equals 2, B equals 2, which means that the period is pi because 2 pi over 2 is pi. And then there's no C in this case, so no phase shift. So that means our first point is going to start at 0 as x. And D equals 1, so our equilibrium was moved up 1, as you can see with the dotted line. And you can see from the graph how that one complete wave is pi. And the amplitude is 2, and it's constantly 2, as you can tell, which means that this graph is in simple harmonic motion. Okay.
Now we're going to talk about some real-world examples of simple harmonic motion. First, we have earthquakes, tidal waves, radio waves, springs, and
sound waves, and also sunlight waves.
So not only does sunlight have, over the course of simple harmonic motion, but also its sun rays, those are simple harmonic motion waves.
Mm-hmm.
We feel those by feeling the heat of the sun.
And we can tell because heat is constant, it doesn't really fluctuate that much. So that's how we can tell that it's in simple harmonic motion. And yeah. Oh, and also to add with our model, just a picture, we can tell from the points that since over the course of the year, the different times they fluctuate, they start at max and they go down to the min and then back to the max, which is about equivalent to the start, that the sunrise and sunset are in simple harmonic motion. So yeah, that's how we determine, and that's how it explains our model. So yeah, I think that's it.
All right, that's it. Thank you guys.
Bye.
Bye.